Hi, and welcome back. In this lecture, we'll focus on one of the main indexers that everyone working with pandas must know how to use well, the iloc indexer. In fact, you might be interested to learn that the flexibility associated with indexing tools, such as iloc, is precisely what helped pandas become the preferred Python data manipulation and analysis library by professionals. So let's carefully examine iloc to understand why. The documentation states that iloc is a property, but in practice, we can also refer to it as an attribute indexer or an accessor. We use it for purely integer location-based indexing for selection by position, which is where its name comes from. I for integer and loc for location. Since we'll be using iloc to index or access parts of pandas objects, we'll call it the iloc indexer or the iloc accessor. The same rules apply for indexing Python lists, indexing series by index position, and indexing with iloc. The reason is that Python handles list and array type structures, such as the pandas data frame, in the same way. What distinguishes the iloc method is using the strict implicit integer location position-based indexing. So let's import the lending company CSV dataset and see the iloc method in practice. We'll also create a copy of it. We'll call it lending company data and use it to explore the features of the iloc accessor applied to a real-world dataset. For starters, if you try to employ the classical indexing operator, whether by providing one or two integers as positions of interest, you will obtain an error message. Instead, if we want to retrieve the column located in position 1, for example, we should refer to its label, which is product. You can rely on iloc if you'd like to implicitly index by an integer. Let's see how. If we execute lending company data.iloc with an index of 1, we'll get the second row of our dataset. In this case, the value of 1 acts as a row specifier, or row indexer. However, when applied on a data frame, the iloc accessor can specify the location of the desired subset by providing a column specifier as well. To do that, we need to add a comma, a whitespace character, and the value of interest. That value will be the column position we want to use as an identifier. For instance, let's use the value of 3 to obtain information about the location of the second loan application. Execute, and we obtained location 6 as a result. We specified the second row and the fourth column as indexing starts from 0. We subtracted 1 from both positions. And as you can see from the previous line of code, it's precisely where we'll find the location 6 entry. Great! As you can see, the iloc accessor has been programmed to deliver the desired portion of the dataset, whether we provide 1 or 2 location specifiers. However, it is well known in the professional world that iloc can use both a row and a column specifier. Therefore, good practice requires us to indicate a value for both. In other words, it is always better to be explicit rather than implicit about the rows and columns of interest during subset selection. In that case, how can we obtain the entire second row from our data frame by using iloc? Well, to do that, we should execute iloc, open bracket, 1, comma, colon, closing bracket. In other words, colon is the symbol we use to indicate all data from all rows, or as in our case, from all columns. This time, let's use iloc to retrieve the entire location column from our data frame. To achieve this, place colon, comma, space, 3 in brackets, and execute the cell. Nice! Remember to always use the accessor specifiers in pairs. This approach is more straightforward to interpret, and that's why it's typically chosen by professionals. To verify the type of the obtained objects, we can pass each of the last 3 expressions as an argument of the type function. When we were specific about the row and column of interest by providing the values 1 and 3, we retrieved a single data point. That's why the type function delivers its data type, a string. Loosely speaking, when we've used the colon symbol to indicate that we want to obtain an entire row or column, the type function output represents the object type of the result. In these 2 cases, that's a pandas series. To conclude, we'd like to step on the syntax structure of the iloc indexer we just discussed to show you how to access several specific rows from your data frame. Assume we want to obtain the entire second and fourth rows. To retrieve these records, we need to place a list containing the integers 1 and 3 before the comma, and then use the colon symbol to indicate we're interested in obtaining all row values. We can use the same strategy to retrieve entire columns as well. To do that, we can specify in the brackets of the iloc indexer, colon, comma, and then use a list that will act as a column specifier. Please note that we are allowed to change the order of columns. So, using 3 and 1 as values in our list will result in a data frame containing the entire location and product columns in that order. Fantastic! These were the main principles to stick to when indexing data from a data frame with iloc. Next time, we'll discuss using the loc accessor. See you in the next video.